Hi everyone, in this video I'd like to start working on some symmetry on the unit circle stuff. So circles are wonderful, they have a ton of symmetry. Any line you draw through the origin will cut the circle exactly in half and give you two mirror images, two halves that are mirror images of each other. So you have symmetry across any line through the origin. We would like to look at symmetry across the y-axis, symmetry across the x-axis, and some symmetry across y equals x. Oh, you can't see that one down there, symmetry across y equals x. I'll do it on two different circles so they don't get too messy. Our goal is, given x, y, and t information about one point, we should be able to use the symmetries I just mentioned to find 7 other points on the circle. And as I said, there's tons of other possible symmetries to use, but those are the ones we want to be somewhat aware of. So I'm going to do this in general, and then I have a more specific example that I would recommend you pausing and trying to do on your own if you're feeling okay after watching this. So let's see, if we use symmetry across the y-axis, there should be a point straight across over here. I think the x and y coordinates part should be fairly easy. It's the t value that gets kind of interesting. So if this was xy, this will have the same y, but it will have the opposite x. So opposite of xy, that's my x and y coordinates. But then the question is, what is the t value that lands me here? And there's more than one correct answer always. There's infinitely many t values that land at this point, but we're just hoping to find kind of a nice easy one. So I would go looking for this one. And what I would say is it should be related to the t that you started with. So if I flip across the y-axis, which is what I'm doing, symmetry across the y-axis, this t lands right here and should end at our point. So this is length t, but remember, when we're talking about our t values, we always want them to start over here at 1, 0. I don't know how much you can see that yellow pen. So we know that this is t units back from this side of the circle, from -1, 0, but we want to know how far it is from 1, 0. So what we need there is the difference. If we know that all the way around to the other side is pi units, and that from here to here is t units, and what we want is from 1, 0 to our point, we need to take the pi minus the t units. So again, sorry guys, rocky ride. The arc length that we're actually getting is this one that I drew right here. That's pi minus t. But it is okay to think about it as, if you go around pi and then come back t, you end up at this point. That's not really how we would do it. We would figure out what pi minus t looks like, and we would just go that far. But that's a way to figure out where you would end up. So the difference between pi and this t gives us this distance right here. Okay, we should also be able to do symmetry across the x-axis. So we can do it first for our original point, right down here. And hopefully we can see that we get the exact same x value. So here I didn't draw the triangle last time, but you can. It just flips this little xy triangle upside down. We now have the opposite y value. So again, I think if you're paying close attention to where you're at, that it should be pretty easy to figure out your x and y coordinates. T can be a little trickier. So I drew all over it, but my original t was from here to here. That was my original t. And that means that when I flip, my t lands right here. And I'm just going to go ahead and draw it in, not using a different color, because that does start at 1, 0, which is fantastic. That's where we want it to start. It just goes the opposite direction. So to get to this point down in quadrant 4, we would have to go opposite of t. There's one more point that I want to do on this picture, and then I'll move down below. Here, let me just draw on this triangle so we're seeing all of them. So here was the triangle for this one. And then there should be a point, and we can use a couple of different choices. There should be a point down here that's straight across the y-axis from x negative y, or straight across the x-axis from negative xy, whichever one you want. So it will have the x coordinate opposite the one we started with and the y coordinate opposite the one we started with. Okay, so there's x and y coordinates. We also want to be able to figure out a t value. So again, it doesn't matter which one you pick. If you're saying I took this point and I flipped straight across the y-axis, then your arc length would flip and land here. We'll draw a dash right here. That would be t. If you took this one, which was a t, and flipped it upside down, you'd have your length t right here. But again, when we give a t value, when we give an arc length, it doesn't help me to have the arc length from -1, 0. I want to know how far I am from 1, 0. So here I think there are a couple that are fairly easy to pick out. One would be you could start and you could go pi and then an additional t. That would land you there. You could go -pi plus t, which is really just from here to here. -pi plus t would leave you this, or -pi plus t, t minus pi would leave you this little bit of negative distance. So whichever one you like, both of those are fine. I'm going to do this one because it's a little bit easier to spot. So that all the way around is a pi plus a t. Okay, so there's a set of 4 points that all have really nice symmetry with this xy point. And I want to find, so really there's only 3 new points here. I want to find 4 more new points by using some symmetry across y equals x, and then we can just convert right back to, once we get a point from that, across the y-axis, across the x-axis. Okay, so new circle, same point, but just so that we don't have quite as much of a mess. So I'll start blue this time. If we want to flip across y equals x, this point flips across to down here. Flipping across y equals x, remember, switches your x and your y coordinates. So it flops this triangle over on its side, and what was your x becomes your y, and what was your y, this is very crooked looking, becomes your x. So this is at x, y. Oh, this is at y-x. I just said they switched, and then I didn't get it there. Y-x is where this is. The t value is kind of funny to look at. So we can take the starting point for our arc length t. It's 1, 0, so it flips up to 0, 1. And then the end point, xy, flip back to here. So now I'll try not to draw it right over the top of the green so we can still see the green. This is our new, oh, I should have dashed that. That's how long t is. That's where t ends up. But we want to say how far we are from 1, 0. So this is what we really want right here. And that is pi over 2 minus t. So this whole thing is a pi over 2. If we subtract off t from that, we're left with this length right here, pi over 2 minus t. Okay, so this gets us something a little bit different to work with. We could continue, we could try and flip across y equals -x and do some other interesting things, but I would say from here we can just go back to flipping across x-axis and y-axis, and it'll get us 3 other interesting points. So if we flip across, oh sorry, yawns, if we flip across the x-axis, we'll get a point with the same x coordinate as this blue point, which was actually y. And we'll get a point with the opposite y coordinate, so -x, opposite x. And our t value, our arc length, also just flips across. So this is -pi over 2 minus t, which you could write as -pi over 2 plus t. Or you could rearrange again and you could make it t minus pi over 2. Any of those, either of those last two look pretty good. I think you should get rid of the parentheses probably. Okay, so it's definitely going to end up being a small negative arc length. We should then be able to flip across, let's see, let's take this one and flip across the y-axis. So straight across. Compared to the original point, this point will have the opposite x coordinate, so that'll be a -y, and it'll have the same y coordinate, so that'll be plain old x, opposite y, x. The arc length, let's see, so before we were visualizing that our length t landed up here, so if we flip across, here we'll just dot this, this is where t lands. we don't just want to say where t is. We want to say how far we are from 1, 0. So that's a pi over 2 plus t. So here, I guess I'm going to totally obliterate my t, but hopefully we'll still be able to tell what was going on. So this whole thing is a pi over 2 plus t. Okay, and then last one, and you can draw in these triangles if you want. They look kind of funny when I flipped across. You can also flip-flop them and draw them this way. It doesn't matter. Last one, we can either flip across this way, or we can take opposite y-axis and flip across the x-axis. It doesn't matter. Either way, you should get opposite y as your x-coordinate and opposite of x as your y-coordinate. So again, we flipped across y equals x. It switched our x and our y-coordinates, and then flipping across axes will change their signs. If we imagine that we flip from here, since that's the one I actually have a t drawn on, t was this length from the point to the y-axis. So when we flip that, our t length ends up here. So again, a couple of choices on this one. In quadrant 3, I actually usually have 2 that jump right out at me, whereas a lot of the other ones, I don't have that second one that really looks obvious when I first look at it. I think I would probably go with all the way around this direction, which is going to be a negative pi over 2 minus a t. You could also do 3 pi over 2 minus a t. That would land you there, which is really from 1, 0 to our point. This distance right here is 3 pi over 2 minus t. So multiple correct answers on the arc lengths. So don't immediately get upset if you don't have exactly what I had. It might just be a different version of the same location. They're coterminal angles, right? So there are different rotations that land you at the same point. Okay, so that's the first one. Thanks for watching. In the next one, I'll work through an example. So it would be a good one to pause and try on your own if you're comfortable.